This is a revision video on electric motors, and this is for higher tier students and triple students only. In the last video we talked about how a wire carrying current generates a small magnetic field, and if we have that surrounded by permanent magnets, those magnetic fields interact, a force is generated, and as a consequence of that the wire will move. Electric motors work off the principles of the motor effect, and what the motor looks like is a coil of wire. A coil of wire, and surrounded by that coil of wire are permanent magnets. And it works using the principle of the motor effect. The only difference is we've got this coil of wire. So current flows through the coil, which generates a small magnetic field, which interacts with the permanent magnetic fields of the north and the south poles, which generates a force which causes movement. But we've in effect got two wires in between these magnetic fields. So what happens is we get force upwards in one direction, and then we can find out the direction using our left hand rule. Line the current magnetic field lines are north to south, and the force is pointing upwards. If the force is upwards on this side of the coil, the force will be downwards on the opposite side. So the forces are in always opposite directions. And this coil is attached to an axle and something called a split ring commutator. The split ring commutator swaps the contacts every half turn to keep the motor spinning. So split ring commutator keeps it spinning. Keeps the motor spinning. Every half turn by swapping the contacts. And just like the motor effect, we can increase the size of the force. So we increase the size of the force by using stronger magnets, or bringing the magnets closer together, or putting the coil at right angles to the permanent magnetic field lines. We can increase the current. We can bring the magnets closer together. We can also increase the number of coils. If we increase the number of coils in between the permanent magnetic fields, we've got a greater length of wire carrying current. If we've got a greater length of wire carrying a current, we'll get a bigger force or make the motor spin faster. We can also reverse the direction of the motor by swapping the magnetic poles around. That would reverse the direction the motor spins. Or we can swap the power supply around, swap the terminals around, so positives negative, negatives positive, or we can turn the battery around. That will also reverse the direction the motor spins.